Hello students. Now we are going to discuss some important gas laws related to gaseous state. In the last class we have discussed Boyle's law and its graphical representation and some important numericals also discussed. So today we will discuss some other important gas laws, Charles law, Avogadro's law, that combined gas equation and that is ideal gas equation. So first we will discuss now Charles law. Charles law mainly is a relation between the volume and temperature of gas at constant pressure. Here the volume how related to temperature at constant pressure, that is related to Charles law. The statement of Charles law is like this: volume of a given mass of gas increases or decreases by 1/273 part of the volume at 0 degree Celsius for every 1 degree rise or fall of temperature. Very important thing, the statements indicates that if you increase the temperature of the gas, the volume will be increased. If you decrease the temperature, volume will be decreased. How much volume will increase by increasing temperature? In the statement it is given. What? If you increase the temperature for 1 degree, if you rise the temperature 1 degree, how much volume will increase? Initial volume, with initial volume 1/273 part of the volume at 0 degree Celsius will be added. With initial volume, before increasing that volume gas has, with that volume 1/273 part of the volume at 0 degree Celsius will be added. That for rising temperature. For decreasing temperature, volume will decrease how much? 1/273 of the 0 degree volume at 0 degree Celsius. So let V0 ml is the volume of gas at 0 degree Celsius. This is the volume at 0 degree Celsius. So what is the volume at 1 degree Celsius? If the volume will be 1 degree, that means how much? 1 degree increase. If 1 degree increase, as per the statement, initially it was V0 plus as temperature increase means volume will increase. How much increase? Initially that volume it will be added with V0/273. Why? Because as per the statement, for every rise of temperature 1/273 part of the volume at 0 degree Celsius will be added. So usually the volume at 0 Celsius, for how much increase for 1 degree? V0/273 will be added with initial volume. So this is the volume at 1 degree Celsius. So what will the volume at 2 degree? 2 degree will be 2 V0 at 2 degree Celsius, like this. So let the temperature at T1 degree Celsius. At T1 degree Celsius, volume will be how much? V0 plus T1 V0/273. This much volume. This volume is taken as that how much? V1 ml. Let it be V1 ml. Similarly, what will be the volume at T2 degree Celsius? It will be V0 plus T2 V0/273. This much ml. Let it be V2. Suppose this equation 1, this is equation 2. This is the volume of the gas at T1 degree Celsius. This is the volume of gas at T2 Celsius. So what is the volume here? Here this is the V1 volume at T1 degree Celsius. This is the V2 volume at T2 Celsius. Let it be. So if we divide equation 1 and 2, if equation 1 divide equation 2, what we will get? This equation is V0 plus T1 V0 by 273 upon V0 plus T2 V0 by 273. As per the equation, this is V1 and this is your V2. We have taken this value taken as V1 ml, this value taken as V2 ml. If you arrange this one, what will the value? Now that will be, you see, everything cancel. What will retain? V0 will common, it will cancel. So it will be 273 plus T1 by 273 plus T2 is equal to how much? V1 by V2. But we know T1 is the degree Celsius. This is the degree Celsius. When with degree Celsius 273 added, that is called Kelvin scale. So that is, let it be T1. Second factor is T2 is equal to V1 by V2. Now here the condition is already here, condition for temperature, volume of greenhouse gas decreases for how much? 1 by 273 part of this volume adjustment for every 1 degree of temperature at constant pressure. At constant pressure. Pressure must be taken constant. So T1, T2, now you are getting V1 by V2. So T1 by T2 is equal to V1, V2 means if you arrange this one, V1 by T1 is equal to V2 by T2. That means V by T is a constant. What does it mean? V by T is a constant. That is K. As V by T is K, that means what indicates? V proportional to T at constant pressure. When pressure is constant and the mass of gas is constant and pressure is constant, V is directly proportional to T. So this is the derivation of Charle's law. V proportional to T, that is V1 by T1 is equal to V2 by T2. This is the derivation of Charle's law. Then how can you express this law graphically? Graphically, already we have discussed. If you draw a graph that suppose V versus T absolute temperature, this is the Kelvin temperature. The graph will be like this. Suppose this is the P1, this is P2, this is P3, different pressure. The graph is plotted at different pressure. This is the, what is the relation between P1, P2, P3? When you see, when temperature is constant, suppose this is the temperature, constant temperature. When temperature is constant, as volume is increasing, pressure will decrease. That's why P3 less than P2 less than P1. This is the derivation. First representation volume versus Kelvin scale for the gas at different temperature, volume of the graph, volume of the gas plotted at different temperature at different pressure. So when the graph is increasing, the volume is increasing at particular temperature, means pressure is decreasing. This is the graph. This is the first graph. Second graph, if you draw like this, the second graph will be like this. Here, suppose this is your V and this is your small t, degree Celsius. The graph will be as at a degree Celsius, this is the 0 degree Celsius, but we know at 0 degree Celsius volume will not be 0. As 0 degree Celsius volume is taken as V0. So the graph will not start from origin, it will start above the origin, it will be like this, the graph will be like this. So if you extrapolate the graph, it will reach at a particular point. At this point volume is 0, but temperature is how much? Temperature is minus 273 degrees Celsius. This is the temperature at which, this is the temperature axis, this is the temperature at which volume of the gas is 0. So if you use this one, here you can write here one thing here. If at T1 centigrade volume is this much, if temperature is minus 273, then volume will be how much? V0 minus 273 into V0 by 273. This much of volume will decrease. Minus means volume will be decreased. At T1 degree, T1 is multiplied. T2 degree, T2 is multiplied. At minus 273, it will be multiplied. So this will be cancelled. The result will be total volume will be 0 ml. So this is the graph. At this temperature, the volume of gas is 0. That is minus 273 degrees Celsius. So this is the important graph for the. Now, if you draw the graph in this way, that graph will protect V by T. V by T versus V. V by T versus V graph you draw. The graph will be constant. Suppose this is P1, this is P2. If V is constant, suppose V is constant, if do like this, as if you see, as V is taking constant, if V is constant, but your V by T is increasing. V by T increasing means temperature is decreasing. Temperature decreasing, pressure is decreasing. Because V is constant. At this point, V is constant. V is constant. But V by T is increasing. V by T increasing means temperature is decreasing. Temperature decreasing means your pressure is also decreasing. That's what is the relation between this? P2 less than P1. This is the graph. As the volume is remaining constant, so as the V by T is increasing, as V by T is increasing, that means temperature is decreasing. That's why V by T is, what happens? V by T is increasing. If temperature decreasing, we know when volume is constant, temperature decreasing means pressure will also decreases. That's why here the graph is become upward and the relation between P1 and P2 is P2 less than P1. So this is the important graph of the what? Charles law, and this is the derivation of the Charles law. Similarly, we can discuss. You write down, complete this one, then I will erase your board. Complete it. Okay? 10 ml of gas. 10 ml of gas. Temperature changes to 17 degrees Celsius to 27 degrees Celsius. 10 ml of gas, its temperature changes to 17 to 27. Then what will be the final volume? What will be the final volume of the gas if temperature changes 70 degree to 27 degree and initial volume was 10 ml? But here one thing remember, here the pressure is not mentioned, means regarding no that data of the pressure, that means pressure is taken as constant. So here as per the question here you see T1 is, as the temperature is Celsius degree, but you have to convert into Kelvin scale. How much? T1 will be 17 plus 273, that is how much? 290 K. Similarly, your T2 as per the question 27 plus 270, that is 300 K. This is the temperature change. And V1 as per the question, V1 is equal to 10 ml. Then V2 is question mark. You apply the formula. What? V1 by V2 is equal to T1 by T2. Here V1 is how much? 10 ml. So 10 by V2 is asked, and T2 is 300 and T1 is 290. Then what is the value of V2? V2 is equal to 10 into 290 by 300. That is how much? 2900 by 300. That is 29 by 3. That is how much? 29 by 3 means how much is coming? V2. 10 ml of gas, temperature changes to 17 to 27. Then what will you get? How much? Calculate it. How much? Here just I have written wrongly. V1 V2 is equal to T1 by T2. Okay, correct. T1 by T2. Here T1. Data written, but data written wrongly. T1 means 290. T2 is 300. Okay. So V2 will be how much? 300 into 10 by 290. That will be how much? 3,000 by 290. That means how much? 300 by 29. Here 300 by 29. 300 result is 300 by 29. It will be how much? Approximately 10 point something. Result will be 10 point something. If you put 1, that is 30, then remaining 10, then 100, that is 10 point something. That means that result will get here 29. 29 means 1, that is 10, in point 100, 33, that is 4, approximately 4 ml, 10.4 ml. So this is the volume of gas at 27 degree Celsius. So in this way you can calculate the first problem. Then another important application of Charle's law is why the tire of the vehicle burst during the summer. Why? Sometimes it is observed that the tire gets bursted due to mainly when the temperature is more, due to friction of the tire. Due to more friction, the temperature of the tire increases. Due to increase in temperature, the gas temperature increases. When gas temperature increases, the volume of the gas, volume of the tube or tire will be increased. That's why as V is proportional to T. Then what happens? The volume of the tire increases during friction. When the volume increases, then it can be expanded to a certain limit. But when the expansion is maximum and further increase in temperature, what happens? The volume remaining constant means temperature will be increased. V proportional to T at constant pressure, but P proportional to T at constant volume. So when the temperature increases, volume increases, but when the tire or tube attain the maximum volume, then further increase in temperature, what happens? The volume will not be increased, the pressure will be very high. When pressure will be very high, then automatically the tire will be bursted. So this is the very important application, that during summer we have to give low pressure. We should not give high pressure to the tire, because with the running tire, the temperature of the tire will be more due to friction, the volume will increase, that's why it may be bursted. So this is the one important application of Charle's law. Then what is the Avogadro's law? What is the Avogadro's law? According to Avogadro's, that the volume of a given mass of gas, volume is directly proportional to the number of particles, number of molecules, number of atoms. But condition is at constant P and T. Both P, T should be constant. If you take more amount of gas, the volume will be more. For example, already you have seen, when you inflate the football by putting some air, then if you give more air, if you put more air into the football, then the football volume will be increased. Because volume is directly proportional to number of molecules. If you take more gas, you occupy more volume. So at constant temperature pressure, volume is directly proportional to N. That means equal volume of gas contains equal number of molecules at constant temperature. If the temperature pressure is constant, same volume of every gas contain same number of molecules. This is your Avogadro's law. Very important, this theory. Then if you combine this combined gas equation, there is a formula, combined gas equation. What is the combined equation? Can combine gas equation only combining Boyle's law and Charle's law. If you combine Boyle's law, that V inversely proportional to P at constant, V proportional to inversely proportional to P at constant T, and second Charle's law, V proportional to T at constant P. This is the Boyle's law and Charle's law. This is your Boyle's law, this is your Boyle's law, and this is your Charle's law. Boyle's law and Charle's law. If you combine it, what you get? V proportional to 1 by P into T. But we know in mathematics, if x, y, if both are proportional related, then when both are combined, then the proportionality factor will be combined, it will be multiplied. Then V proportional to 1 by P and V also proportional to T. But here, when both P changeable, both when it will be changed, this factor will be considered, because there is a first factor, your T is constant but P changeable. When I apply second law, your T is constant, P changeable. When combined, both will be changeable, not constant. So V proportional 1 by T. If you combine it, V is equal to some constant K T by P. Then if you arrange it, imply P V by T is equal to K. This is your combined gas equation. You can write P1 by V1 by T1 is equal to P2 V2 by T2. This is the change in volume. When the pressure will be changed, then volume will be changed, then temperature will be changed. Both are changeable. P1 V1 by T1 is equal to P2 V2 by T2. And this, if you draw the graph, you can take like this. This is your P V by T versus suppose T. The graph will be constant. Like this. Graph will be constant. Constant graph will be obtained. So this is the derivation of what? This is the graph representation of combined gas equation of PV by T versus T, PV by versus P, PV by T versus V. Every graph will be parallel to the what? X-axis, because PV by T is always constant as per the combined gas equation. So, but one thing remember, here we have to remember standard temperature at STP, standard temperature pressure is taken as 1 atm as pressure and 0 degree Celsius as standard temperature. 1 atm and 0 degree Celsius. 0 degree Celsius means 273 Kelvin. So this is the what? STP. At STP generally pressure is 1 atm or equivalent to 760 mm of mercury, and temperature will be 273 K. You have to remember this thing. And at this condition, 1 mole of gas occupies 22.4 liter volume. That is called molar volume. This is called molar volume. What is molar volume? The volume of gas, 1 mole of gas. So you have to take 1 mole. 1 mole of gas at 1 atmosphere pressure and 273 Kelvin, the volume will be 22.4 liter. So this is called molar volume. So this is regarding what? The relation between P, V and T when both are changeable. This factor combined gas equation used when both are changeable. And when only one factor will be constant, other will changeable, it may be Boyle's law, it may be Charle's law. And but when P and T is constant, only N will be considered. So So let us discuss one problem, numericals. Okay, you write down completely first. Complete it. We'll discuss some numericals. Okay, one problem we'll discuss regarding combined gas equation. Let oxygen gas of volume 10 liter, oxygen gas of volume 10 liter at a temperature 17 degrees Celsius and pressure 2 atm. Oxygen gas, the volume is 10 liter oxygen gas taken in a cylinder, suppose in a container, at temperature 70 degrees Celsius and the pressure is 2 atm. Okay? Then question is, what will be the volume? What will be the volume at STP? What is the volume at STP? What is the volume at STP means we know. So here data you see volume V1, suppose V1 is given how much? 10 liter. What is T1? T1 is given 70 degrees Celsius means 17 plus 273 300 K. And here pressure P1 is 2 atm as per the question, 2 atm. Then what will be the volume at STP? STP means here T2 is equal to 273 K. Already I have told you STP standard temperature is generally considered 0 degrees Celsius or 273 K and pressure will be 1 atm. As pressure is given in atm, you will write in atm. So V2 is asked. What is the value of V2 is asked? We know the formula that P1 V1 by P1 is equal to P2 by T2. You put this value, P1 is how much? 2, V1 is 10 and T1 is 290. T1 is 290. And here 290, then P2 as per the code that 1 atm, STP means 1 atm, 1 V2 is asked, and T2 is already how much? 273. So what is the value of V2? So V2 is equal to, that is 20 into 273 by 290. So this is the value of V2. That you get, it will be in the ml. Liter, it will be in the liter, because question given we have put in the volume in the unit liter, so answer will be liter. So P1 V1 is 2 and V1 is 10, T1 is 290, P2 is 1 atm as STP and V2 is asked and T2 is 270. If you put, you will get what? Value of V2. So in this way we can solve different types of problems related to Boyle's law, Charle's law and combined equation. Now we will discuss very important thing is that ideal gas equation. What is ideal gas equation? This is very important also. Ideal gas equation, generally we know that the gas when obey all gas laws, Boyle's law, Charle's law, Avogadro's law, that is called ideal gas. If the gas is obeying the gas laws at different conditions of temperature and pressure, that is called ideal gas. So ideal gas means it obey Boyle's law. As per the Boyle's law, V inversely proportional to T. Here at constant what? Constant P, T and N. N means amount of gas also or number of moles also constant. Then Charle's law, if you take V proportional to T, here are constant P and N. This is your Charle's law. Then if you use Avogadro's law, that is V proportional to N, here R constant, P and T. Here this is the three laws. If the gas is ideal gas, then it will obey all three laws. Three laws can be applicable to the ideal gas because they are obeying. So V proportional to P, V proportional to T, V proportional to N. If you combine, already I have told you, if you combine, then V is proportional to what? 1 by P into T into N. Then there will be a proportional equal to some constant R, then NT by P. Then if you arrange this, that is now you are getting PV is equal to nRT. So this is the derivation of what? Ideal gas equation. It is called ideal gas equation. Ideal gas equation. What is R? R is called universal gas constant. This universal, why it is called universal? Because it is constant for all gases. There is no, if you change the nature of a gas, there will be no change in R. So R is constant and it depends upon units of measurement. What units you are using, what type of units you are using, that depends upon the R depends. But R does not depend upon the nature of gas. It is always constant. That's why it is called universal gas constant. PV is equal to nRT. And if you change this formula, this is an important formula. So if you apply P is equal to N by V RT. Here N by V means number of moles for volume of the gas. But if you put this, P is equal to N is W by M into V into R into T. Then P is equal to W by, here W by V, mass by volume density. So D by mRT. This is another relation. Here molar mass of M is the molar mass because number of moles is mass by molar mass. So molar mass is constant for the gas, R is constant. If temperature is taken constant, that means P also that is proportional to D. P is also that is proportional to D. Condition is temperature is constant. T is constant. T is constant. This is important derivation. So this derivation also important. Calculation, pressure related to density, molar mass, R and T. Here P, V and RT all are called what? Ideal gas equation. PV is equal to nRT. What is the significance of R? Significance of R. As per the derivation, PV is equal to nRT. PV is equal to nRT. If what is the value of R? R is equal to PV by NT. PV, pressure and volume, if you multiply for any gas, there is work done. That means there will be work done. Work done upon N and T. N means number of mole, T means absolute temperature. So R has significance means R is related to amount of work done by the gas per mole per degree change in temperature. If you change the temperature of gas taking per mole of gas, then how much work is done on the system or by the system? That work done by the system or work done on the system, that is related to R. So R is nothing but the energy. R related to energy. Energy means amount of work done per mole for T. So what is the unit of R? If you put this, so you can derive like this. R is equal to PV by NT. If P is atm and V will be liter, then N will be 1 mole and T will be here 273 Kelvin. Then R will be, if you put this value, R will be 0.0821 liter atm per degree per mole. So this is the unit of what? R. Very important. If R will be in liter atmosphere, value will be 0.081. You put this value like this. R can be also expressed in terms of joule. That pressure is, if taken Newton per meter square, and volume will be in meter cube. Then R will be how much? 8.314 joule per degree per mole. Per degree per mole. This is the unit of R in MKs in joule. Then if you convert it into calorie, R will be 1.99 calorie per degree per mole. So remember, this is a very important value of R. R can be expressed in terms of liter atmosphere per degree. R can be expressed in terms of joule by putting pressure is Newton per meter square, volume in meter cube like this. This is the 8.314. Then R will be 1.99 calorie. So this is the expression of R. For R has unit, R has R is a dimensional constant. It is not non-dimensional. It is a dimensional constant. It has unit, and this R is constant for all types of react, but only vary when you change the units of measurement. So this is regarding the expression of R. Then one problem we will discuss regarding your ideal gas equation. Problem is like this: calculate the volume of a gas. Let it be, calculate the volume of a gas. Suppose oxygen gas at volume of oxygen gas volume of suppose 8 gram. Calculate the volume of 8 gram oxygen gas at 70 degrees Celsius and 2 atm pressure. You see the data. Calculate the volume of the 8 gram oxygen gas. Here mass of oxygen gas is given and volume is asked, but condition temperature this much and pressure is this much. So here mass, temperature and pressure, that means we have to use N related to N. So we know PV is equal to nRT. We can use this formula. Here what is the value of P? P is here, P is 2 atm. What is the V is asked? V is question mark, and your T is given 70 degree means 290 K. Then N is already know. What is the value of N? 8 gram oxygen means how much? Oxygen molar mass 32. 8 gram means it will be 1 by 8 by 32, that is 1 by 4. 1 by 4 mole. 32 gram is 1 mole. 8 gram is equal to 1 by 4 mole. N equal to 1 by 4. So P, V, T, R value already know. R is given in atmosphere means this value will be used 0.0821. So now what is the value of volume? We will put the data. So P is how much? 2. V is asked. N is equal to 1 by 4. Then R is 0.0821. Then T will be how much? T is 290. You put this, then V will be how much? V will be 0.0821 into 290 upon 80. So that value will get. It will be the answer will be liter. Answer will liter, because we already have taken the R value in liter. Liter atmosphere per degree per mole. So the volume will be calculated in the form of liter. So in this way you can calculate which formula use in for different problems. You have to think, you can know from the data given. So you have to practice more for different types of problem. Okay, thank you all.